Hi, I'm Dr. Incognito. In this video, we're going to explore a polar curve. We'll sketch the graph of the curve, we'll find the equation of a tangent line to a point on the curve, and we'll find an area related to the curve. So the example we'll look at is r equals 4 sine theta. It turns out that the graph of this curve is a circle. That might not be so obvious directly from the equation. We could plot a few points, and if we're lucky, we might recognize it as a circle. But what we'll do to determine that it's a circle is we will convert the polar equation into rectangular form. If we multiply both sides of this equation by r, it becomes r squared equals 4r sine theta. And then using the conversion equations, r squared equals x squared plus y squared, and y equals r sine theta. So using those, we can transform this equation into x squared plus y squared is equal to 4y. Now subtracting 4y from both sides, x squared plus y squared plus negative 4y is equal to 0. To determine that this is a circle, we would like the form x minus h squared plus y minus k squared equals some number squared. This r is not the same as the r in our polar equation. This would be a circle with center hk and radius r. So here we have x minus 0 squared, and we would like to turn these two terms, y squared minus 4y, into a perfect square. We can do that by adding 4 to that quantity. So we have to add 4 to both sides of the equation. This adding 4 is called completing the square. Y squared minus 4y plus 4, hopefully we recognize as being y minus 2 quantity squared. So now we can clearly see that our equation r equals 4 sine theta, which corresponds to this equation, represents a circle with center at the point 0, 2, and radius, that's r squared is 4, so the radius is 2. So our circle looks like this. The circle is centered at 0, 2, and has a radius of 2, so it goes through the origin, and it goes through the point 0, 4. So there's our circle. Okay, so we have sketched the polar curve. Now let's find the equation of a tangent line to a point on the curve. So suppose we let theta equal pi over 4, then r would equal 4 times the sine of pi over 4. That would be 4 times the square root of 2 over 2. That would be 2 times the square root of 2. So in other words, the polar point 2 root 2 comma pi over 4 is on the circle. And that point would be at an angle of 45 degrees. Let's say it's there. So this is our point 2 root 2 comma pi over 4. Those are the polar coordinates of that point. This is the x-axis, and this is the y-axis. So let's see if we can find the equation of the tangent line to the circle at that point. To find the slope of the tangent line is given by dy dx. dy dx. We're working in the xy plane, and so dy dx is the slope of the tangent line to the curve. Basically, this notation comes from delta y over delta x, rise over run. In calculus, when dealing with curves rather than lines, dy and dx become infinitesimally small, as they used to say. So delta y over delta x, but very small, even smaller. So in order to calculate dy over dx, given r equals 4 sine theta, where there's not an x or a y in sight, we have to convert this into what's called parametric form. So we should have x equals something and y equals something. And then once we have the parametric form, there is a formula for dy dx. That would be dy over dt, assuming t was the parameter. It won't be in this case. And divided by dx dt. Our parameter is actually going to end up being theta. So let's have a look. How do we create the parametric form? The conversion equations that we use are x equals r cosine theta and y equals r sine theta. We already used the bottom one earlier. So that will give us the x equals something, y equals something situation. In this particular case, since r is equal to 4 sine theta, it gives us x equals 4 sine theta cosine theta. And it gives us y equals 4 sine theta times sine theta is 4 sine squared theta. So this is the parametric form of the equation. And so therefore, dy dx, a formula for the slope, will be dy d theta divided by dx d theta. So let's calculate those derivatives. dy d theta using the chain rule will be 8 sine theta times cosine of theta. And dx d theta using the product rule will be 4 sine theta times negative cosine theta. Four sine theta times negative sine theta plus cosine theta times 4 cosine theta will be 4 cosine squared theta. So you better double check that. Let me simplify it, and then to find the slope of the tangent line, we will plug in the angle pi over 4. So this is equal to, this derivative is equal to 8 sine theta cosine theta divided by, I'm going to rewrite this as 4 times cosine squared theta minus sine squared theta. Now there are some identities that could be used here. First we can cancel 2 sine theta cosine theta divided by cosine squared theta minus sine squared theta. If you're really good at trigonometry, then you probably recognize 2 sine theta cosine theta as the sine of 2 theta, and you recognize cosine squared minus sine squared as being the cosine of 2 theta. So that would simplify our work a little bit if we recognize that, but let's just suppose that we didn't, and we'll use this form that anyone can obtain algebraically. So our slope, the slope of our tangent line, which I'll denote by m sub tan, is equal to dy dx evaluated at theta equals pi over 4. Remember, the problem is to find the equation of this particular tangent line, and that line occurs when the theta value is pi over 4. So the slope of the tangent line will be here's our derivative. We'll plug in pi over 4. The sine and the cosine of pi over 4 are both the square root of 2 over 2. So in the numerator, 2 sine pi over 4 cosine pi over 4, and in the denominator, cosine squared of pi over 4 minus sine squared of pi over 4. Something interesting is happening. The sine and cosine of pi over 4 are equal. This denominator is going to be 0. The numerator is going to be some number. My graph is a little off. The sine and cosine, if you're calculating this, that's the square root of 2 over 2 times itself. That's a half times 2 is 1. And on the bottom we get 0. We get 0. So it looks like the slope of our tangent line is undefined. But that's okay. We're undeterred. Our tangent line is vertical. It is vertical. We have a vertical tangent line. So the equation of the tangent line will simply be, the equation of the tangent line will be x equals a constant. What constant is that? It's the x-coordinate of this point. Is this the x-coordinate of the point? No, this is the r-coordinate. This is polar coordinates, r theta. The x-coordinate is r times the cosine of theta. So our r value at that point is 2 root 2, and our theta value is pi over 4. So this is 2 root 2 times root 2 over 2. So our x value is 1. So the equation of the tangent line is the vertical line x equals 1. So the picture is a little bit misleading. Probably the circle is poorly drawn. That tangent line should be vertical. Clearly the circle has vertical tangent lines on either side. It just so happens that they occur at the angle 45 degrees, pi over 4 radians. Okay, we will discuss area, in fact the area that's here in this little section of the circle, in the next video. Thank you for watching.